In this problem, we're going to be adding polynomials. So the first problem that I have set up here is more of a combining like terms. And then the second problem actually delves into adding and subtracting polynomials. So to start this off, in the first problem, whenever you're combining like terms, you need to make sure that your terms are exactly alike. We don't care about the number or the coefficient in front of each term. All we care about are the variables, the x's, y's, z's, and so on. We need to make sure that when we combine two terms together, they have all the same variables, so in this case x and y, and then they have the exact same exponent on each variable. So, in this case, we have 2x squared y. Now we want to check if any other term in this polynomial has an x that's being squared and a single y. So, if we look at our second term, we have a single y and an x squared. It doesn't matter the order. When you're multiplying, order is the same. Order doesn't have any effect. For instance, 2 times 3 times 4 is the same thing as 4 times 3 times 2. Both will result in 24. So, 2x squared y plus 3yx squared is the same thing as 2x squared y plus 3x squared y. These two terms are like terms, so we can add them together. And when we add them together, we're going to keep the variables exactly as they are. So x squared y, and we're going to add the coefficients or the numbers in front. So 2 plus 3 gives us 5. And we're just going to show some sort of arrow connecting the two so that we show the work that we are saying these are like terms. Now let's go through this some more. We have a negative 2yx. The next term has a z, so immediately it cannot be like terms with the negative 2yx. The next term is negative 6xy. We have 1x and 1y just like our first term here, meaning that again, these are like terms. So remember, you always add the numbers in front. We have a negative 2 plus a negative 6 gives us a negative 8xy. You could also say negative 8yx, but in general, you're supposed to put the x first, then the y, then the z. Continuing on with this, we now have two terms left, 4zx squared and just x. These two terms are not like terms because the last term does not have an x squared, nor does it have a z. So, we're just going to copy them down at the end. 4zx squared plus x. And this is the simplified form of our polynomial having combined our like terms. Moving on to the second part, we now are subtracting two polynomials. All this does is introduces one extra step before the problem becomes very similar to part 1. So, the first thing that we're going to do here is take care of these parentheses. So this first set of parentheses around the 5x squared plus 2xy minus 3x are just going to drop away. The reason why they just go away is because there is technically a 1 being multiplied to the outside of them. Remember, whenever you don't see anything, but you have parentheses, which means multiplication, then there's always a 1, technically, that's being multiplied to it. So, these parentheses, when we distribute that 1 to each term, are just going to go away, leaving us with exactly what we had. 1 times anything is itself. So we get 5x squared plus 2xy minus 3x. And now in this case, we have a negative on the outside of our second set of parentheses. Well, since there isn't a number here, again, that means there's a 1. But in this case, it's a negative 1. So we're going to distribute a negative 1 to every term that's being added or subtracted. And whenever you distribute a negative 1, all you have to do is change the sign of each term. So this positive 2y is going to become a negative 2y. This positive 3xy is going to become a negative 3xy. Positive 4x, negative 4x. And then negative x squared becomes positive x squared. And now we have one long polynomial, just like we had in the original problem. So we can start combining the like terms again. Looking at this first term, 5x squared, we're going to start looking through all the rest of our terms to see if any of them has just an x squared. So the first term doesn't match. The second term is closer, but it doesn't have the squared, so we can't combine it. The third term doesn't match. Neither does the fourth, the fifth, but finally the last term, this x squared, does match the 5x squared, so we can combine them together. And remember, you add the numbers in front, and again, if there isn't a number being multiplied out front, then that means there's technically a 1. So 5x squared plus 1x squared means 5 plus 1, or 6x squared. Now we have 2xy minus 3x minus 2y minus 3xy minus 4x. So we'll go through this one a little quicker. We need to see an xy, just an xy. So the next term doesn't match, next term doesn't match, but here we have a negative 3xy. We can combine them together. So we take our positive 2 plus our negative 3, that gives us minus 1xy, or just minus xy, as we don't write the 1 out front, it's implied. Our next term is this negative 3x, and toward the very end we have a negative 4x, that matches, so we can combine the terms together. Negative 3 plus negative 4 gives us negative 7x. And finally, we have one term left, our negative 2y. There's nothing to combine that with, so we just put the negative 2y in our final answer, which gives us 6x squared minus xy minus 7x minus 2y.